All right, so we are trying to take production. That is for question 2. Question 2 is production. So let's write production here. Now, what are the factors of production?
Say capital and land.
Factors of production. We'll go with the acronym CEL. We have CEL. We have CEL. We have capital, entrepreneur, we have labor. So for the course we are going to do today, we are interested in capital. We use the acronym K to represent the capital, and labor, the acronym L. These together gives us what is called inputs, mainly inputs. These inputs will help us generate what is called output. So KL represents the output. So the KL can represent the production units, or the output. So that is what we are going to use. The KL represents the output or production units. So back to what you are going to say. In production, we have the short run and we have the long run. Now, in the short run, in every business, for revenue, total revenue, for sales, for profits, right? The business aims to achieve maximum, highest of it. Every business wants to achieve more profits, maximum, more sales, maximum, more revenue, maximum, more income, maximum, more gains, maximum. But when it comes to losses, when it comes to costs, when it comes to expenses, the business always wants to produce at minimum costs. The business always wants to incur minimum losses. The business always wants to incur minimum expenses, because if your cost of production is minimum, then and your revenue is maximum, then you can get maximum profit or you can get higher profit. Are we good?
Yeah.
Good. So these two gives us what is called the optimal level. What are the two extremes? We are talking about a maximum extreme, revenue, sales, profit, and the minimum extreme, loss, cost, expenses. So optimal or optimum. Optimal level, which is the adjective, and optimum. So in all the cases, the business wants to achieve optimal level. If it is revenue, the optimal level is the maximum. If it's sales, profit, the optimal level is maximum. If it is loss, cost, expenses, the optimal level is to incur all these at minimum. All right, so don't forget them.
Okay.
Now, let me clear them here. So, in dealing with the production, long run and short run, we say that, just as I wrote, at optimum, at maximum, at minimum. The same on this side. At optimum, at maximum, or at minimum. So at optimum, at maximum, at minimum. Or if it's in the short run, we go with the acronym, we go with the equation wage equals VMPL, or wage equals PMPL. Are you good?
Yeah.
So another word in the question, they can use wage, they can say wage, or they can say the rate, cost of labor. So cost of labor. So they can say cost or price of labor. Cost or price of labor. I getting it.
Yeah.
I getting it. And also the P is the same as the V. So the P here, yellow, I'm using yellow, is the same as the V there. So you can use W equals VMPL or PMPL. Are we okay?
Yes, please.
Good. So in the short run, at maximum, optimum, or minimum, you state this formula. Then when you go to the long run, we go to the long run. We go to the long run. In the long run, we will say that MRTS, marginal rate of technical substitution, is the same as saying MPL over MPK.
Please come again with it.
Why in the long run, the right hand side, at optimum, maximum, or minimum, we say MRTS equals, okay. Let me first come up with this. Hold on. I have to explain something first. Let me clear this. I'll come back to it, but before that, let me do this. So in the short run, right? In the short run, the I told you we are looking at two inputs. What are the two inputs?
Revenue and
Madam, be careful.
sorry, capital and labor.
Okay. So those are the two inputs. So in the short run, capital is fixed. Capital, which is K, is fixed. When I say it is fixed into brackets at a number of units, that means it is fixed at a number of units. And labor is variable. So capital is fixed at a number of units. At a number of units. And labor is variable. What I mean by capital is fixed and labor at a number of units and labor is variable, I mean to say that the question will give you the unit for the capital. I get it. The question will
Yeah.
give you the unit for the capital. So if the capital is 4 units, the question will state in it in the passage that it is 4 units. So you will solve for labor. So if the question says capital, if it's a short run, the question will give you the question will give you the capital units. So when you say capital is fixed, it will provide the units. Is it 4 units, 3 units, 2 units, 1 unit, 8 units, 10 units? You state. But then the question will ask you to solve for labor. All right. So I'll come back to this. Now let's go to the next slide. At optimum or maximum in the long run. In the long run, whether at optimum means it could be maximum or minimum. In the long run, the capital, both capital and labor are what? Variable. So if it's a long run question, the question will ask you to solve for both capital and labor. Do you get it?
Yeah.
So if it's a long run question, the question will ask you to solve for both capital. So in the long run, both capital and labor are variable, so you solve for the figures. But in the short run, the question will give you the value for K in the question, in the passage, in the case study, or in the scenario. And then it would ask you the requirement to solve for the variable, the L, the labor. But in the long run, the question will ask you to solve for both labor and variable. So now, in the short run, at maximum, okay, we say that. So in the short run, capital is fixed, but labor is variable. Then we proceed. We proceed. So back to what I was writing. In the short run, W wage is equal to what? V MPL. Or you can say that, wage is equal to PMPL, where the wage can be described as the cost my stylus pen is broken. Oh, I have to get a new one. Okay, I'll use the other side to write. I was like, new one.
Sorry.
Come again. Come again.
I just said sorry. Sorry about that.
Oh, okay. I'll get the guy to give me a new one. I'll buy a new one. So it's a cost or price of labor. So in the question, it could be that they will not state the word wage. They can say the costs or price of labor. I hope you get it.
Yes, sir.
So that's it. So now we would say that, so whenever it's in the short run, labor, capital is fixed, labor is variable. And at optimum or maximum, we will state this formula down. Now, in the long run, where both capital and labor are variable, we will say that the MRTS, so is the marginal rate of technical substitution, equals MPL. I'll explain what MPL means. Marginal rate, marginal product of labor over marginal product of capital. Are you getting it? So the
Yes.
marginal rate of technical substitution is that if labor, marginal product of labor changes by 1 unit, by how many units would MPK change? Well, those two, I can plot a graph of labor against capital. If labor change by this unit, how will capital also change by that unit? Are you good? So marginal rate of technical substitution. As labor changes, how does capital also change? So now we will say that MRTS equals MPL over MPK. So when I also say that MR M when I also say that MRTS equals wage over rate. wage over rate. Okay. Now, so if I want to replace the MRTS, what will I replace it with? Okay. When I say A equals 2, it means that in the equation, wherever I see A, what does it equals?
2.
Equals 2, right? So I've written MRTS equals MPL over MPK, and I say MRTS equals W over R. So I want to replace the MRTS, marginal rate of technical substitution. What should I replace it with?
Um, the marginal product of labor.
That's correct. I get it.
Yes. Yes, please.
All right. So this is what I want to arrive at, but I wanted to explain some few things because sometimes in a question they could state this MRTS. It's the same as the MPL. We can say it's the same as the MPL over MPK. Now, you could see from the short run that I equated wage to VMPL, right?
Yeah.
So if you want to remember how the marginal rate of tactical substitution is, the MPL, the MPL will be equal to the wage, just as in the short run. But in the short run, we add the V. Do you get it?
Yeah.
Have you seen it?
Yes.
Look at So if you want to remember how the long run formula is the MPL without a V is equal to the wage. The L goes with the wage. Then the over MPK equals the rate. Then the MPK will go with the rate.
Okay.
Have you seen it?
Yes.
Yeah. And this MPL, MPK, it is the MRTS, marginal rate of technical substitution. Okay. So now we are done. Let's move on. So whenever now we're going to solve the question. These are just intros for you to understand. Sometimes the question can ask you, is the firm operating in the short run or long run? How do you know it's operating in the short run or long run? You just have to read the requirement first. So let's go to our question. Let's go to our question, which is on the right. Okay, we are reading question 2. So whenever you are giving the question, the first thing to do is to read the requirements. The A, B, C, D, whatever you're asked to find. You have to read the requirements first. Because production question, you must first ascertain whether it's a short run or long run before you start. And you can identify that by reading the requirement first. So, madam, read the requirement. Let's see.
Determine the amount of labor the firm should employ to maximize profit.
Okay. So, what were you asked to find?
Labor.
So, having noted that you're going to find labor. Now, back to my explanations. Are you going to work in the short run or long run?
Short run.
Why?
Because you are asked to find for only labor. Labor,
Thank you very
for
much.
labor is variable, and
Thank you
the
for
capital is fixed.
Yes. So, meaning that the question will give us for fixed. That's the first. That's what we have to do. All right. So, let's start reading it. Let's solve the question. Question 2. Start. Let's start. A cement manufacturing firm has the following short run production. So even here they said it's a short run, but assuming they didn't even state a short run, from the A requirement, you know it's a short run
Yeah.
because you are only asked to find labor. Yeah. So
Okay.
where what is the, let me write the equation here. K equals 5KL plus 10L minus L squared. All right, good. Where K is the number of cement bags produced, L is the amount of labor used, K is the capital input. That is fixed in the short run at 2 units. So they give you the fixed unit. Assume further that the costs. Let me take my time. A cement manufacturing firm has the following short-run production function: K equals 5KL plus 10L minus L squared, where K is the number of cement bags produced, L is the amount of labor used, K is the capital input fixed in the short run at 2 units. So here the question has given us the capital units at 2. That is why it only asks us to find for labor. If it were a long run, the long run will tell us from the A that we should solve for both capital and labor. Then it tells us the question is long run. So since we've noticed that it's short run, all that it means is that every information I'm going to deal with, they will fall under the short run. At optimum, at maximum, capital K is fixed at number of units, which we've gotten to know from this question that is 2, and labor is variable. Because labor is variable, that's why we're going to solve for it. So we know we're going to go with that formula at the maximum formula for the short run, which is W equals VMPL or W equals PMPL. That's what we're going to use for the question 2 because it's a short run question. All right, let's proceed. So it says, assume further that the cost per unit of labor, you see here, they didn't use wage, they said into bracket wage rate. So here it says the cost per unit of labor, so they use cost of labor, is 20 cedis, cost per unit of capital is 50 cedis, and price per bag of cement is 10 cedis. A. Determine the amount of labor the firm should employ to maximize profit. You could see it has used the word maximize. So whenever it is a profit, the business has to maximize it. So maximize the optimum level for the short run, the optimal level for the short run, SR. If it's profit, they have to maximize it. So having taken notice of this, if it were loss, they will say to minimize losses or to minimize cost or to minimize expense. If it's profit, to maximize profit. If it is revenue, to maximize revenue. Okay, let's proceed. We'll finish soon. Okay, so the first thing we will do is the question has already given us the value for K. So where K equals 2. So I'll plug it into the equation. Wherever I see K, I'll replace it with 2. So 5 is multiplying K. So 5 times K and the K is 2 times L plus 10L minus L squared. So I'm going to have K equals 5 times 2 is 10L plus 10L minus L squared. So I'm going to have here to be K equals 10L plus NL will give us 20L minus L squared. So now I've reduced the former equation or the initial original equation, which had a K in, to an equation of a function or equation of K against L. Why? Because K is on the left-hand side, L is on the right-hand side. So it's an equation of K against L, having substituted the 2 with the K. Now, having gotten this, then I'll write my introduction. Let me write as an introduction. I'll say in the short run, it's in the short run. So this is just as a reminder. If you wish, you may not write it. So in the short run, if you wish, you may not write in the short run at maximum. Why? Because you're dealing with maximum profits. So if you wish, you may not write it. In the short run at maximum, what was the formula? W equals what? VMPL. W equals VMPL. All right, let's see. Now, what is the value of W in the question?
W is 20.
So I'll replace it with 20. The V here represents the price. Like I said, it is the same as W equals PMPL. So the V here represents the price. What is the price?
The price of labor.
What is it? What is the price? Can you see
10.
it? Yeah, it's 10. So 10 is here. And multiply the 10 times what? MPL. Are you getting it?
Yes, please.
So we have to go and solve for the MPL. We have to go and solve for the MPL. What is the MPL? MPL equals. Now, whenever it's marginal product of labor in economics, let's say when we talk about marginal, we're talking about the change in the product of labor. So the M, which is marginal, we use calculus, it will be the D over D. That is the M. Then the P is production. And what did we say? What is the variable which is used to represent production units? But what is the variable used to represent production units? Check your note.
From the equation.
No. What is the variable used to represent production units or output? The P there is representing
Q.
production units. Come
Q.
again.
Q. Q
Good.
for
So yeah. So the D, you can, if you wish, can write it this way. It is okay. But I also write it this way. Delta. So pay attention. The marginal product of labor. So I will say the marginal gave me the D in the numerator, D in the denominator. So I should differentiate P, the production, and K is used to represent the production unit, which is the K. Then I'll come and differentiate the second one with L. Have you seen it?
yeah.
So the marginal gave me the D in numerator, D in denominator, and the P. So it is marginal product. That's the marginal output at the top, K. Marginal labor, DL in the denominator. What it means is that I should go to the equation which starts with a K, the K equation. When I write an equation like this, profits equals total revenue minus total cost. I'm explaining because we'll be doing more of this. Minus total cost. What it means to say is that this profit, the owner of this equation, the name of this equation is called profit equation because it's a dependent variable or it is the one beginning the equation. So it's called profit equation. If I write TR equals P times Q, it's called revenue equation because revenue is the beginner of the equation. And TC is a term of the equation, TR is a term of the equation, and profit is the owner of the equation. So what the DQ is saying is that I should go to the Q equation. So let's say here, go to the Q equation. And in the Q equation, differentiate all terms with L. All terms with L. So assuming I have, let's say I have y is equal to 4x squared plus 5x plus 2. I'm differentiating. So if I should differentiate, the owner of the equation is a y. So I'll say differentiate equation y over which term, which variable in the equation should I differentiate? Differentiate x.
X.
So I'll be searching for x. When I get to the first term, which is this term, to differentiate, I'll multiply 2 by 4. Then x, I'll subtract 1 from the 2. That means I've differentiated. I've differentiated a 4, followed by the plus, which is this plus. Then the 5. The x has an exponent of 1, right? So 1 times 5. I'll show a shortcut quickly. So this is not the thing because I just want to explain the concept. Then plus 2. Whenever it's a constant, when we change it, we will get 0. I'll explain why. So let's go. So we're going to have dy dx equals 2, 4, 8. 2 minus 1. X 2 minus 1. There's 1 here. But the 1 is not written. Because when the variable stands alone, it has an exponent of 1. Then followed by plus 1 times 5, 5. X has an exponent of 0. Then the other one is plus 0. It's not written. So whenever, let's say, whenever a variable raised to power 0, or anything raised to power 0, we say it's 1. So we're going to have dy dx equals 8x still, because I've not differentiated this again. I'm just repeating it. Plus 5 times 1 5 times 1 will give me 5 plus 8x equals dy dx. So this is the derivative of the equation I've written above, this equation. The equation I've written above, here, that's the derivative. Do you get it?
Yeah.
All right. So now, what are we trying to see? Whenever, watch you, whenever, look at the 5x, you have a term or a variable with a coefficient, let's say here, this variable 5x, the coefficient is 5, but the exponent of the variable is 1. This x, the 5x, the x has an exponent of 1. So this 5x, that's the exponent of 1. That's it here. So we subtracted 1 from it. We multiply the 1 by the 5. If you can't say it's 0, because whenever it is 0, it will change to 1, but it's not 0. So whenever the exponent of the variable is 1, just as the 5x's, the coefficient is the derivative is the coefficient. So we could see that here, because it is 5x, what was the final derivative? It was the coefficient. Have you seen it?
Yeah.
So there's no need for me to do this. There's no need for me to do this. There's no need for me to do this. I'll just write 5. And the
Okay.
2, why is the 2 0? Why is the coefficient? Why is the derivative of the 2 0? Now, remember that when this equation you are looking at, the equation you are looking at as 4x squared plus 5x plus 2, the exponent of the x is in descending order. So 2 is the highest, followed by 1. So the 2 we are looking at, the 2 constant, what will be the variable? What will be the exponent of the variable? 1. The common variable in this question is 2. So it is the common variable is x. X is here. X is here. Then the exponent of this x is 2. That's the highest, followed by x exponent 1. So what do you think the 2 will also have?
Exponent 0.
Good. It's also x exponent 0. But it's not the x exponent 0. So what is x exponent 0? It's the same as 2 times 1, right? No,
Yes.
sorry. Sorry. Yeah, 2 times 1, which will give you 2. But when we are differentiating 2x exponent 0, 2x, 2 exponent 0, if you are differentiating this, let's say y, dy dx will be equals 0 multiply 2. Then we'll subtract 0 from the 1. Will be equal to 0 times 2, 0.
Yeah.
X, 0 times negative 1 minus negative 1 is neg 1. So 0 times x negative 1, what do we have?
0.
So what it simply means is that whenever you are differentiating whenever you are differentiating a constant like this, the final answer is what? 0. So there's no need for you to do all this. There's no need. It's 0. The same way, when you are differentiating a variable with an exponent of 1, the derivative is the coefficient. So I have here y equals 10x. Y equals 10x. Because the exponent has because the x, the variable, has an exponent of 1, the derivative dy dx will be equals 10, the coefficient, because the x has an exponent of 1, which is not recorded. Do you get it?
Yeah.
Okay. So back to what we are doing. I think next time I'll create a space on the right hand side and do these rough works there. Then I'll come back and we'll continue. Let me leave the others. So back to our work. It says we should go to detail which is the equation kill, and differentiate the terms with L. So the first, after the equal sign, the first term, do you have L there?
Yes.
So what is the derivative?
20
20 minus,
L square.
come again?
L square or which one?
Multiply the two. What's the coefficient? What's the coefficient of the L? Do you remember the way I did the 4x squared?
Yes. So
How did I do it?
so one times two.
Which will give us 2.
Two. Then two L raised to the power 2 minus 1.
Which will give us what?
1.
Good. So this will be the derivative. So in other words, the MPL will cause what? 20 minus 2L. Have you gotten it?
Yes, please.
Then we will come and plug it in to this equation because there we got the value for W and V. But the MPL, that's what we just went to calculate. So we've now gotten the MPL. So we will have what 20 equals 10 multiplied by, if you write it this way, it's wrong.
So I'll
If you
put
write it
it in
this way,
bracket.
good. You put it in a bracket because the 10 might multiply only the 20. So we put everything in bracket. Then we expand the bracket. We're going to have 20 equals 200 minus 20L. I good.
Yeah.
Then we group like terms. So 20 crosses from right to the left becomes positive. They're going to have 200 minus 20. This is 180. Then is what? 20L. We have 20 here. We have 20 here. So L equals what?
9.
L equals 9. That's it. So we solve the A. We solve the A. Did I write the question number? Okay, let me write
And
it
please
here.
minutes so that I can write the answer.
So where are you now?
Um, just stay where you are. Please, can you move up? Please, I'm done. Hello, Mama.
You are done with everything.
Yes, please.
All right, that's fine. So that's A. You're done with A. Let's
Yeah.
go to B. So determine the amount of labor is 9. B. How many bags of cement should the firm produce in order to maximize profit? So it's very simple. How many bags? What do you think the question is asking us to find?
Quantity.
Good, quantity. So it's simple. Just write the quantity equation, which is the 20L minus what? L squared. Very good. You can choose this one and you make it KO, where L is what? What is L value?
L.
Where L is 9, right?
Yes,
All
L
right.
is
So we're going to have KO equals 20 into brackets 9 minus 9 squared. So KO equals 29 is 180, then minus 81. So what is our KO? Is that correct?
yeah.
So it's bags. So 99 bags. Are we okay?
Yes, please.
So let's go to the C. Now it says calculate the maximum profit the firm can make. So ordinarily, let's say let pi equals profits. Let pi equals profits. So the formula for profit is equal to what? Total revenue minus total cost, right? So we'll first
Yeah.
come and solve for total revenue. Because don't know they didn't give us anything on any value for total revenue. So total revenue will be equal to what? Price times quantity. What is the price? 10 cities,
Price
right?
is 10.
So from the question, price is 10 cities here. And like we said, the how many bags is referring to the quantity here.
Quantity is 99.
Yeah. So 10 times 99. So what would be our total revenue? 990. All right. So having done or having found the value of total revenue, we'll now come and look out for total costs. Now, ordinarily, total cost function value should be fixed costs plus variable costs times quantity, or total fixed costs plus total variable costs. And the expansion of the total variable cost is this. But in this question, the fixed cost will be assumed as 0. The fixed cost will be assumed as 0. So what we would rather write is two variable costs. So the formula is the wage. Wage, does it associate with labor or capital?
Labor.
Good. So it will be the W times L. So WL plus the rate. It's the rate, this R, which is in the long run, it represents rate, it represents rent, it represents cost of capital, it represents price of capital. So if you remember, we did this. The MPL over the MPK. So MPL equals W over the MPK equals the R. This R is what we are talking about now. So you can also add it to your notes. So this R will represent the rent. It can represent the rent, cost of rent. It can represent rates. It can represent cost or price of capital, right?
Yeah.
Uh-huh. So the R is associated with the L or the K.
K.
So that also multiplies the K. So it's just like saying W times L plus R times K. Are we okay?
Mm.
All right. So now back to what we are trying to say here. Now, the wage, another thing, it is monetary. The wage is monetary. The same way as the rate, it is also monetary. When I say monetary, it's money. So monetary. Then we go with L. The L, the labor is in units. The labor is in units. So the labor here is in units. The same applies to capital, it's in units. So basically what I'm trying to say is that these two are variable costs. So the fixed cost is, it is plus zero, fixed cost, plus zero fixed cost. And I'm saying them because if I'm buying one bottle of water for 10 cedis for one bottle, 10 cedis for one bottle, and I buy 10, madam, how much would that be? And I buy 10 bottles, I mean, how much would that be?
100.
Good. And I know you did this way to get it. 10 cedis monetary times 10 bottles units, right?
Yes.
It's the same concept I'm applying up there so that you don't forget it. But if you are in haste in exams or something, you might, oh, how do I go about this? It's very simple. So the wage is the money. And how much is the wage?
20.
The wage is here, 20. So it's here. So I come here and I put in the wage figure of 20 cities. I'll multiply by the labor units of 9 plus the rates. How much is the rate? The rent or the rates? It says the cost per unit of labor. That's not it. And it says the cost per unit of capital, rental rate. Have you seen it?
50.
It's 50. So that's the rate per unit. So we go here to 50 times the K. How many K? 2. So 2 times 9 is 180 plus 100. So you're going to have 280. Are we good?
Yeah.
Okay. So now we have to find the profits. And from the profit, we've gotten our total revenue and we've gotten our total cost, right? So we come down here and we'll come now fix in the values. So we have our profit is equal to total revenue minus total cost. What is our total revenue? Our total revenue is
100.
990. Our total cost is what? 280. So what do we have?
710.
So that's the profits. So that's the maximum profit. Why maximum? Because we are calculating the short run from the maximum point of view of W equals V MPL. This is the maximum formula, which gave us the labor. So we got the labor, because we've gotten the labor out of the maximum computation, anything we will use the labor value for will give us a maximum value. Are you getting it?
Yeah.
All right. So D, should the firm continue operation in the short run? Explain your answer. D is grammar. Mm-hmm.
Yes, because he has a maximum profit of 710 cedis.
Yeah. Or it has enough revenue to cater for its costs. Are you getting it?
Yeah.
It has enough revenue to cater for its costs. In other words, it is profitable in the short run.
Okay.
Have you written everything down?
I'm yet to write the profits thereafter.
So where should I start from? Where are I going to start from?
So I've written the formulas down. I've gone for the total revenue, and so
Okay.
I'll do for the total cost.
Okay.
Please, I'm done.
All right. So that's it. So let me bring this question. Let's see how you can get it. This is one of the IEs written by one of the students. They didn't even state the dates. Look at the question 3. How do you go about it?
So you're a manager for a measure.
Hey, madam, is that what we said?
I'm trying to read. The
I wish you were
requirement,
nearer me. I wish you were close by.
the requirement. So if
Mm,
workers at the firm are paid a competitive wage of $120 per day, and chairs can be sold for $400 each, what is the profit maximizing level of output and labor usage? So this one is the long run. We are asked to find for a okay, so it's short run. So it's only labor. We are fine for labor. Then output.
that's correct. So it's already labor. So it's short run. But let me make some few points here. So it's just the same approach. The same approach. You first write the kill. Now, this equation is called Leontief. No, this is called Cobb-Douglas. This
It's
kind of
called
equation. Cobb-Douglas.
okay.
Cobb and like Cobb and Douglas. I getting it.
Yeah.
When we invented that equation, that's his name. So the K equals 2K. Hey, let me change this one. K equals 2K exponent 0.5 L 0.5. So it's just the same approach, but just I want to finish with this one. Only this explanation. So this question 3. So when you read as the short run, like we just saw, you have to go and bring the original equation and substitute the K given. In other words, the question will give you the K, right?
Mm,
So in the
yeah.
question, what is the K? Mm-hmm.
9 units of
Good.
capital.
Yeah, yeah, 9 units of capital. So you just go into the equation and substitute just as we did. substitute the k with the 9, then make it 0.5. L 0.5. Now, this 0.5 is for the 9. 0.5 is the same as half. Are you getting it?
Yeah.
Uh-huh. So you don't have to multiply the 2 by 19 and make it 2 by 9 and you obtain 8 and then you make it 18.18 exponent 0.5. That's wrong. You make it this way, it's wrong. Rather, what you have to do is the 2 has its own exponents. The 2 has an exponent of 1 and the 0.5 is for the 9. So you must first change the 9 exponent 0.5, which will give you 3. So you're going to have 2 into bracket 3 because 0.5 is the same as half and half is the same as square root. So another way I can write this is 2 square root of 9, which will give me 2 by 3. Are you getting it?
Yeah.
Uh-huh. So the first thing, what I'm trying to say is that you do not multiply the 2 by 9 to have 18 before you bring the 0.5. If you go by this approach here, the answer you obtain will be wrong and different from the 2 by 3, which will give me 6.
Yes, when I did it, I had 4.2.
Yeah, so it's wrong here because the 2 has its unique exponent, which is 1, the 9 has an exponent of 0.5. So you first change it, then you get 6, right? Then you bring in your L exponent 0.5. This is what you're going to have, right?
Yeah.
Then you go with your wage. It's the short run. So in the short run, at maximum, then we say W equals what? VMPL. So what is our wage? In the I, it says the wage of 120 per day. I says wage of 120 per day. That is the wage, right? And the chairs can be sold for 400 cedis each. That's the price, market price. That's the price. So in the and plug in the values, we are going to have the wage to be 120. Then the value is what? 400 times what? MPL. Are you good? Are you good?
Yeah.
Then we'll come to find the MPL. So the MPL will be equals, right? We will multiply the 0.5 by the 6, which will give us 3, right?
Yeah.
Then L. Then we'll have 0.5 minus 1, right?
Yeah.
0.5 minus 1, which will be MPL equals 3L negative 0.5. Oh, and I understand why your people didn't do my assignments. I think they'll get stuck somewhere. And I understand. So now this is because yesterday I gave them this as the assignment, but I didn't show it in full. So
Oh,
this is the MPL. So we will come and say that 120 equals 400 times into brackets, sorry, into brackets 3L negative 0.5. I think that's why they didn't do the assignment. Okay. So yeah, we are going to make L the subject. So what we must first do is the 1120 equals 400 into bracket 3L negative 0.5. You divide both sides by 400. This will go here. So we are going to have 120 divided by 40. What do we have?
0.3.
So we're going to have here to be 0.3. 0.3 equals 3L negative 0.5. Then you divide both sides by 3. We get rid of the 3. You get rid of the 3. So what are we going to have?
And so here we get 0.1 equal to the L raised to the power negative 0.5.
Let me make it systematically so that those who watch it will understand. So this side will give us 0.1 equals 3 over 3 L negative 0.5. So this will cancel this. We're going to have 0.1 equals L negative 0.5. Now, this is where the issue comes in. I think that's where that they didn't do my assignment. This is where the issue comes in. So now, we are going to change the negative. Are you getting it? We are going to move the negative on the right to the left so that the L can stand alone. I can even use logarithms. Now get this, but let me use this simple method. When the negative crosses to the other side, it's an exponent. Are you good? The negative will now change. This 0.1 is over 1. Do you know that?
Yes.
So when the negative crosses, it will change the position to be 1 over 0.1. That's the power of the negative. So we will now have this, right? And the L exponent 0.5, the 0.5 in the index is also over 1. Do you know that?
The 0.5.
It is also over 1 at the top. As the index is also over 1.
Okay.
Are you getting it? So when the index, the 0.5 crosses the sign, which is 1 over, which is 1 over 0.1, all will be multiplied by 1 over exponent 0.5. Exponent 1 over 0.5 equals what? L. Are you getting it?
Okay, so is it like we are squaring both sides, or you are taking the
Yeah,
zero
yeah,
away?
yeah. The 0.5, I told you it is half, right? So
Yes.
I can also write it this way: 1 over 0.1. Because 1 over 0.5 is like squared.
Mm.
It's like this. The 0.5 is half. So when it crosses the equal sign, turn it upside down. But it's going to affect the entire fraction. So when I turn the 1 over 2 upside down, it's going to be 2 over 1. I get it. And 1 over 0.5 is the same as 2 over 1 or 2. Do you get it?
Yeah.
I don't want to be changing them because it is 0.5. So if I turn it to half and change it, it's just a difficult thing. And just watch. I watch this one. So let's say 1 over 0.1. And we are having L here, and we have 1 over 2, which is the square root. If I should cause it to move to the left, it's going to be 1. If I should cause it, it's going to be 1 over 0.1, 1 over 0.1. Then the 1 over 2 will turn upside down to the left. When I move it to the left hand side, after that equals, so it's going to be 2 over 1 equals what? L. And 2 over 1 is the same as what? 2. Right?
Yeah.
So this is what it's going to be eventually. This is what it's going to be eventually. This. But then if you want to change it to half and others, the issue is what if you go to the, let's say in the exams or another question, it's not 0.5, where you can easily convert it to half. I hope you get it. So
Yeah.
simply, since 0.5 is divided by 1, because when I write a figure of 0.5, when I write a figure of 0.5, 0.5, this 0.5, it has an exponent of 1. It is also divided by 1. Are you good?
Yeah, I'm following.
So this 0.5, which is the L exponent 0.5, when I switch the 0.5 to the left hand side, I just turn it upside down. The numerator becomes denominator becomes numerator. So the 0.5 is over 1. When I turn it upside down to the right hand side, left hand side, the 1 goes up, 0.5 comes down. If it's on the right hand side, the 0.5 is up, the 1 is beneath it as a denominator. Are we good?
Yeah.
So on your calculator, compute the 1 over 0.1 exponent 1 over 0.5.
Hold on. Mm, yes. Yeah. Hmm.
Yeah, what do you have?
100.
You got 100. So it means that L is 100. So this is 100. 100 equals L. So that's we solved. If workers at the firm are paid, the requirement I. If workers at the firm are paid a competitive wage of 120 per day and chairs can be sold for 400 cedis each, what is your profit maximum level of output and labor usage? So we first found the output. How many marks? 4 marks. So we first found the output. You should be able to do the remaining, isn't it? Okay, let's try. Are you online or you've gone? Hello? Okay. So we have to find the outputs, and the output is K equals, we're going to write this formula, this one. That's where you can get that up. Output equals K equals 6L exponent 0.5. 6L exponent 0.5. So 6L exponent 0.5, where L equals 100. So we're going to have K equals 6, 100 exponent 0.5. And 100 exponent 0.5 will give us 10. So 6 equals 6 times 10. So K equals to 60. That's the output usage. Now, all this gives us the solution to the question I. Then when we come to the we find the profits, maximum profit. So profits, let pi represent the profit equals TR minus TC. So TR equals price times quantity. So we have $400 times 60, which will give us 24,000. Then we have our total costs will be equal to the wage times the labor plus the rent times the capital, where the wage is okay. So in this question, the question provided the solution for the wage. It says that, now let me read the entire question. It says you are the manager for a a major office furniture manufacturing company, an economist working with engineering operations experts have estimated the production function for a particular line of office chairs for your company as K equals 2K exponent 0.5 L exponent 0.5, where K represents capital equipment and L is labor. Your company has already spent a total of what? 8,000. So it means that's a total cost expenditure. That's the total cost expenditure. So I'm reading from here. Your company has already spent a total cost of 8,000. All right. So it means that the question has already given us the value for the total cost, which is 8,000 here equals the wage is 120 and the labor is 100. Then plus, we don't know the rate, but we know the capital to be 9 units. Okay. So here, simply put, we can straight away say, if you are solving for the profits, right? We can straight away say that the profits equals the revenue of 24,000 minus the total cost of 8,000, because the person has already given it to us. So straight away, we could just say that the profit is 16,000. That should be the profit, maximum profit. But then, so that is the final answer for the II, just 3 marks. We saw for the revenue, and we have the company has already spent a total of 8,000. That's the total cost on the 9 units. Okay. The company has already spent a total cost of on the 9 units of capital equipment it owns due to economic conditions. Okay. Let me make it this way. Sorry, this is not the right approach. Let me make it this way. Now, we are solving for the total cost. Okay, we are solving for the total cost. So the total cost equals the wage is 120 and the labor is 100. And it says that the company has already spent 8,000 on the 9 units of capital equipment, meaning this is the total cost the company spent on 9. In other words, it's just like saying that the RK, let me use red, just like saying that the RK is equal to 8,000. So if the RK is equal to 8,000 and the K is 2 units, we don't know the R, right? It's going to be 8,000, right? It's going to be 8,000. Then we could say that we are dividing both sides by 2. So R will be equal to 4,000. No, sorry. Oh, what a mistake. The capital is 9 units. I'm using the first example. The capital is 9 units. So we divide both sides by 9. We're going to get the rate to be what? 2,000. So we're going to get the rate to be, let's see. Let me pick my calculator. Grace, are you online? Let me pick my calculator. That is 8,000 divided by 9. Okay, that will give us 888.89. So we could say 888.9. Let's say 888.9. That is the rate. Okay. But then I just calculated the rates for us to know but the question never asked us to find the rates. What the question wanted is the profit. So back to the question, we would say, I'm using the yellow or the gold color. We will say that the 120, which is the wage, multiplied by the multiplied by the labor is 100 plus. Now, remember, both the R and K are all 8,000. So plus 8,000 together. The one I've just said in red is just to show us how to find the rates uniquely or separately from the capital or from the 8,000. So now our TC value is TC equals 120 times 100 plus the 8,000. And the 120 times 100 will give us 12,000 plus the 8,000. And totally, it will give us 20,000. That's the TC, right? Now, the solution in red, it's not relevant because whether we solve it or not, 8,000 is the cost for the whole capital. 8,000 is the total cost of the capital. Very good. Yeah. So the 8,000 is there. And I've just included 8,000 in the equation. So my total cost now is 20,000. So back to the formula of the profits. I have the total profits in black. I'm writing in black. I have the total profits now to be equal to the TR minus the TC. And we got the profits, total revenue to be $24,000. And our total cost to be $20,000. So in total, the profit is $4,000. That is what the question wants us to obtain. So that's it. So what's the maximum profit? The maximum profit is $4,000. All right. So this brings us to the end of our class today.